Wait lang, hulugan mo dahil yata ko
Saan mo nakabit?
Kumain mo. Hello viewers, hello world. This is Rob.
And this is Kobe. And this is Roy.
Your laboratory buddies. For today's video, we'll be conducting a test on the air content of cement mortar. Unlike concrete, which has multiple methods, there's only one standard procedure for measuring air content in cement mortar, a gravimetric method based on ASTM C185. So, without further ado, let's get started. Today, we only have one thing to acquire. Our main objective is to determine the percentage of air voids present within a mortar sample. Starting the experiment proper, first we gotta gather the things we need. That includes materials and equipment. For materials, we need cement, sand, and some water, which will all be measured as we go through the testing. For equipment, some standardized cube-shaped molds, which is typically 50mm cubed to cast the mortar specimens. A mixing bowl and trowel for mixing the mortar ingredients. A balance to weigh the cement, sand, and water for accurate proportions. And finally, a tamping rod for compacting the mortar in the molds. After gathering everything we need, we begin by preparing a mortar mix using specific proportions of cement, standard sand, and water as per the test standard. We thoroughly mix the dry ingredients before adding water. We then add the water to achieve a desired flow consistency for the mortar. Next, we fill the mold with fresh mortar and compact it using the tamping rod according to the standard procedure. We then weigh the filled mold with the mortar. We can now calculate the volume of the mortar by subtracting the empty mold weight from the total weight. This is optional, but you can also determine the densities of cement and sand separately using a picnometer. Here are the written procedures if you'd like to try this test. Now that we gathered our data, let's head to computations. To solve for the air content, the formula is shown above, where P is equal to the percentage of mixing water based on the mass of concrete W. We then get the sum of the results of the three samples and divide it by 3 to get the average. Now, let's compare with the specifications. As you can see, for air content percentage, it must be greater or equal to 8%, and for volume percentage, it should be greater or equal to 21%. Here's the recorded data from our experiment. For sample 1, we got 21.57%, sample 2, 21.02%, and for sample 3, 19.74%. Based on the specifications, only sample 1 and sample 2 passed, since they have values greater than 21%. So why exactly do we need to conduct this test? Well, air content significantly impacts the properties of mortar, such as workability, strength, permeability, and durability. Knowing the air content also allows for adjustments in the mix design to achieve optimal mortar performance for the intended use. This test helps ensure consistent mortar quality and adherence to project specifications. Guess that's all for today. Hope you learned a thing or two. If you're interested in more of our experiments, we'll be uploading a few more videos soon. So please, do subscribe and hit the notification bell to stay updated. Till next time!